In this topic, we're introducing the concept of latent heat, and latent heat is symbolized by capital L, and this is the formula that latent heat is commonly used in. It is used to calculate the amount of heat that is involved with a phase change. So whether it's a solid to liquid, like as in something melting, maybe like ice melting into liquid water, or if it's liquid into gas, like perhaps evaporation or water boiling, there is heat involved with that. In other words, like if you have water evaporate, it turns out it needs to absorb heat to do that. And of course, when water is boiling, it might make sense that you need heat for that, but it's pretty much the same thing. If you want to convert a certain amount of liquid water into a certain amount of water vapor, you're going to need heat. But if you want to calculate how much that is, you need to know, in that case, the latent heat of vaporization for water, and then multiply that by the amount of mass of water that's being considered. Now, another kind of latent heat is the latent heat of fusion. And so if you wanted to know, like, say, how much heat is involved with a certain amount of ice melting, you would take the mass of that ice multiplied by the latent heat of fusion for water to calculate that. Note that that doesn't include any temperature change. So if I say ice melts and I'm going to calculate that with latent heat, I'm assuming that's 0 degrees Celsius ice turning into 0 degrees Celsius water. If instead I said, well, let's say the ice starts at some negative, say 15 degrees Celsius, how much heat does it take for it to become water that is 15 degrees Celsius? Well, that's going to involve some heat to simply warm the ice up to 0 degrees Celsius, and then as well some heat to warm up the now water after it's melted from 0 degrees Celsius to 15 degrees Celsius. And our first example is going to be similar to what I just described. So in that sense, this latent heat is just another ingredient for calculating the total amount of heat for a process that involves a substance going from one temperature to another, but where maybe somewhere in between there is also a phase change that happened.